As I said, I'm George Papadatos, and I'm joined by my colleague Mark Davis. We'll give you a brief overview of SureChEMBL in terms of coverage and content and its current capabilities. And then we'll spend some time on what we are planning next for the improvement and development of SureChEMBL, of this resource. And this will be followed by a live interface demo. Right. So both Mark and myself are members of the ChEMBL group at the EBI, the European Bioinformatics Institute. And what we do in ChEMBL is we manually extract bioactivity data from the primary medicinal chemistry literature, so from journals. And then what we do is we organize, integrate, curate, standardize, normalize, and further annotate the data that we collect, and then we provide them back with added value to the community in terms of, in the form of insights, publications, tools, and resources that hopefully facilitate the modern drug discovery process. So we do this for journals, for medicinal chemistry literature, and people have been asking us for many, many years, are we going to do the same with the patent literature? Well, and this opportunity presented about a year ago, and that's what we're going to talk to you about. So, why is searching chemical patents useful? Well, there are lots of reasons. There are legal reasons and there are technical reasons. For example, somebody would like to search in what we call the freedom to operate, so to avoid areas of valid patent protection by somebody else. Or another reason would be competitive intelligence. So if you would like to find out how productive or what research topics or research fields a company have been active in. But what is a fact is that the knowledge that appears in chemical patents will never appear anywhere else, not in journals or nor books. But if it does appear, the average difference between, let's say, a chemical series that appears in a patent document and in a journal publication is about 3 years. So the chemical series that you see now, let's say, published in the Journal of Medicinal Chemistry, the chances are that the same chemical series were published in a patent document about 3 years ago. And when we talk about knowledge, the wealth of knowledge in chemical patents, we talk about compounds, chemistry in general, new scaffolds, or new reaction schemes. And in addition, when it comes to bioactivity and biology, we're talking about biological targets, diseases, and interactions between compounds, diseases, and targets. So, and for these reasons, chemical patent searching have been, I guess, a commercial field. Right. Let me give you an overview of SureChEMBL. So SureChEMBL used to be SureChem. SureChem used to be a commercial product, a commercial chemical patent mining product that was that used to belong to Digital Science, which was part of the Macmillan Group. So in 2013, December 2013, the EBI acquired SureChem. And SureChem used to have 2 types of users. So there were the free users that had access to a limited version of the interface, and there were also the paying customers that had license and had full access to all the functionality provided by the interface and the API. So during the transition period, EBI supported the existing users, and then since last September 2014, EBI provides an ongoing free and open resource to everyone. We have exposed the full functionality of the interface, and we plan improvements when it comes to the data, the interface, the infrastructure, etc. And the last thing that we did is that we rebranded SureChem to SureChEMBL, which wasn't a very difficult thing for us. this slide summarizes how the SureChEMBL system works. As I said, there are patent feeds from the 4 main patent authorities. These feeds are processed by a third-party company called IFI Claims, and then the SureChEMBL pipeline starts. So there is the entity recognition that will go into the unstructured text of the patent document and try to recognize entities, chemical entities, in the form of IUPAC names, for example. And once this is done, there are 5 different name to structure tools that will try to convert the entity into the corresponding structure. The new structures will be registered to the database, and at the same time there's another branch of the pipeline. Patent documents also contain images, and these images will be converted by another commercial tool called Clyde. It will be converted to the corresponding structure, and again the new compounds, the new chemistry will be registered to the database. And this database is exposed to the users, to the audience, to the community via the interface application. So, and this whole system runs in the cloud, in the Amazon AWS cloud. So there are 2 things to notice here. First of all, this is a fully automated and unsupervised process. So every day there are new patents that are published by the authorities. So there's a new patent feed, and this feed is submitted automatically to the SureChEMBL pipeline. The entities are extracted, the names are converted to structures, etc., etc. And also this is a dynamic process. So as I said, every day there are new patents, there's new chemistry, and other chemistry is registered into the database and then is provided via the interface. And the extraction is automated. So this is by means of text mining and image mining, and this is to be compared with the extraction in ChEMBL, which is manual, both the extraction and the curation. Right. So, in terms of chemistry data coverage, SureChEMBL contains structures that are extracted from text for patent documents since 1976 onwards. As I said, when we say patent documents, we mean the full text, so all the sections of a patent document, the title, the abstract, the claims, and the description. And then the entity recognition will try to find all different representations of entities, that's IUPAC names, trivial names, trade names, fragments, etc. For the entity recognition, we use a proprietary algorithm that came with the acquisition of SureChem. And then for the conversion of the entity to the corresponding structure, we use 5 different name to structure tools. 4 of them are commercial, and Opsin is an open source one. As I said, we do the same thing for images. For that we use Clyde for the image to structure conversion, and this is done for patents from 2007 onwards. Finally, there is a third source of compound information, and that's the complex work units. So complex work units are provided by the USPTO since 2001, and the inventors, when they file a patent application, are required to provide mol files of the drawings that are included in the patent document. So what we do in SureChEMBL, the SureChEMBL system has access to these mol files, and they are also part of the pipeline as a third source of compound information, and this is done again for patents from 2007 onwards. Right, when it comes to data content, as of today, the 11th of March 2015, there are more than 16 million unique compounds in the SureChEMBL database that come from more than 13.2 million annotated patents. The rate of growth in the system is really staggering. We have about 80,000 new compounds that come from 50,000 new patents every month. That's about 2 new compounds every minute. And And also, because the system is fully automated and dynamic, the turnaround time is really, really small. So it takes only 2 to 7 days for a patent to be published by the authority to the chemistry, and the patent being available and indexed and searchable within the SureChEMBL system. So as you can see, it's really, really fast. And finally, one other thing to notice is that the SureChEMBL interface provides querying capabilities to all patents, not just the chemically annotated ones. And that's a total of more than 120 million patents in total. Right. So at the EBI, we have a number of chemistry resources. ChEMBL is one example, ChEBI is another one, and SureChEMBL is now part of the chemistry resources available at the EBI. So the EBI resources, in addition to third-party databases, third-party compound databases, such as Zinc, for example, or PubChem or JunkBank, are all available and searchable using the UniChem system. So the UniChem system is our INCI-based chemical resolver. You provide an INCI string or an INCI key, and it will quickly do a lookup and bring back whether this compound exists in more than 30 different sources. And INCI and UniChem has access to more than 80 million unique compounds at the moment. Right. So in addition to the interface, there are other ways to access the compounds and in general the data from SureChEMBL. So as I said, one thing that you can do is use UniChem to do quick lookups against SureChEMBL. UniChem is updated every week with the new compounds that come from SureChEMBL, and UniChem provides web services, so you can use programmatic access to do a quick lookup using your the INCI key of your compound of interest and search quickly against the SureChEMBL database just to see whether this compound exists or not. This is a form of a novelty check, so to speak. If you want another way to access the compound repository in SureChEMBL, there is also an FTP download on our FTP server. So you can follow this link and you can have access to the full compound repository extracted by SureChEMBL in both SDF and CSV format. And we plan to update this repository with quarterly, so every 3 months we will produce a new file, an incremental update that will be added to the FTP server and will be available to you. So I think the next one actually comes in 2 weeks. So around the beginning of April, we'll have a new file available for download. Right. There are also other ways to access the SureChEMBL compounds. SureChEMBL is now a data source in PubChem. So the compounds that are available as the FTP file download, they're also available and integrated in PubChem. And finally, there is another way to access the data in SureChEMBL using the data feed client. So what this does is it's a script that accesses our FTP servers, and it creates a local copy, a local replica of the SureChEMBL database to your machine or your server. And this is updated daily, and it kind of mirrors the data that we have in SureChEMBL. So if you want to find out more about this new way to access the SureChEMBL data, follow this link. And then if you're interested, you can send us an email to surechembil.help@ebi.ac.uk asking for more details. You will need a couple of credentials to access so that the script accesses the FTP server. Right. Can we have everything? So as we saw, there's a very good coverage of the patent authorities, and the system is very, very fast extracting the chemistry from new patents. But I guess in software and in most things in life, things are a compromise. between these three factors, so cost, time, and quality? Well, when it comes to cost and SureChEMBL, it's easy because SureChEMBL is free. When it comes to time, as we saw, SureChEMBL, because it's fully automated, the turnaround is really, really quick from new patents to new chemical annotations. So what about quality? So we have noticed that there are some common sources of errors when it comes to SureChEMBL. For example, patent documents often include images that are parts of tables, and then the images there are very small and poor quality. So when Clyde tries to convert the image to the corresponding structure, it will make mistakes. Maybe a bond will break or a ring will open, and that will result in the wrong structure stored in the database. Furthermore, there are OCR errors that occur when it comes to IUPAC names, for example. For patent authorities such as the WIPO and the EPO, there is a step, an OCR conversion step, because the patent feed is provided as an image of a text. So we need to scan this image and convert the image to characters, and this is done by this third-party vendor, the IFI claims company. So when this happens during the OCR conversion, there will be some errors. So there will be some spurious characters that are inserted. So in this example, the N will become a Greek capital lambda and a slash, and then some brackets will be lost, and some other spurious characters will be introduced. And although we have an OCR correction step in place, this example, for example, is beyond any rescuing, and this will be a false negative, a miss. So SureChEMBL will not manage to convert this to a corresponding structure. And as a general comment, the reliability and the accuracy is much better in US patents. First of all, because they don't need this OCR conversion step, so there are no OCR errors because the patent feed, the original patent feed is in XML. And also because, if you remember, US patents offer the third source of compound information in addition to text and images, which is the MOL files. Right. This is a question that many people ask. As we saw in the beginning, in ChEMBL we do our main thing, I guess, is the extraction of bioactivity information from the medicinal chemistry literature. And people have asked us many times if we do the same thing in SureChEMBL. The answer is no, we don't do at the moment bioactivity data extraction from patent documents. And the reason is simple. This is an automated process, and it's very, very difficult for an automated process to parse accurately bioactivity data from patent documents. So this is an example of how the bioactivity data are reported in a patent document. So you have a table. The first column has the compound name, and then the name of the target is in a header in another column, and then you have these cross signs, and then somewhere else in the patent document there is a legend that explains what these cross signs means, and this is very difficult to parse using an automated text mining method. The other thing that people ask us all the time is if we do Markush structure extraction from the patent documents in SureChEMBL, and again the answer is no, and again the reason is the same. It's very, very difficult to parse the Markush structure and all the specifications and store them in the database. And again, here is an example. So you have the Markush structure here, and you have the specifications, and then you have the different variable points in the image. So you would have to map the variable points in the image with the variable points in the text, and then of course the points have different values. And as if it was not enough, there's another nested Markush structure. So L is a linker, and it's a Markush structure on its own. So it's a Markush within a Markush. And then again, there are different values for these variable points. You have to enumerate this and put them all together and produce structure. So this is not to our own, well, this is very difficult to do. Having said that, there is a group in Germany called InfoChem that they have tried to do something like that, an automated Markush structure extraction and enumeration via text mining and image mining, and they have reported some success. But as far as we know, this is a very, very difficult thing to do. Future plans. We receive a lot of emails with feedback and questions, and I guess the main theme is about the compound to patent map. So although we have already released the full compound repository in SureChEMBL, people ask us for the links between the compounds and the corresponding patents. So which compounds occur in which patents. So this will be available very soon. So within the next couple of weeks, there will be a flat file available to download via our FTP servers, and it will include the full link between compounds in SureChEMBL and the corresponding patent documents. So it will be very easy to, for example, submit a list of compounds and find a list of the patents that they occur in, and vice versa, submit a list of patent documents and fetch all the compounds that they include. We are also planning to update this regularly, and the same map will be available in UniChem as well. So again, you will be able to use UniChem, the interface and the web services, to submit an INCI, for example, or a list of INCIs, and find quickly the list of patents that these INCIs have been extracted from. The other big thing that we are preparing is we are planning to complement the chemical annotation in patents with biological annotation. So this is part of the OpenFacts ENZO project. So what we're planning to do is we're going to use biological entity annotation software and try to find mentions of proteins, genes, and diseases in the patent corpus, and store these along with the existing chemical annotations.